Okay, so it's what we're doing today goes along with what we've been doing the last couple of days, where we're focusing on inequalities on a graph. But this today and tomorrow is going to go over systems of inequalities. Systems of inequalities is two or more linear inequalities. And the solution is the solution of the overlapping regions, okay, of points that satisfies both inequalities. So let's go over it. So number one, we first have to always make sure that both equations are in slope-intercept form. So here we're going to have to convert. So I'm going to do the first one. I'm going to subtract x to both sides, so y is greater than negative x minus 1. On the second one, I'm going to subtract x, so negative y is greater than negative x plus 5, where I have to divide by negative 1. When I divide by a negative, I flip that inequality, so negative x over negative 1 is positive x, and positive 5 over negative 1 is negative 5. Now I'm going to graph both. So the first one, we're going to start at the y-intercept of negative 1. The slope is negative 1, so over 1, we're going to go down 1, right 1, 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 up 1, left 1 to go the opposite direction. Okay, just like the last couple of days, since it's greater than, that means it's a dashed line. Okay, and since it's greater than, we're going to shade above, but we're going to wait. What I'm going to do now is just kind of tell myself, okay, we're above this line, so that means I'm going to shade in this direction. And you'll see why I do the arrows here in a minute. The second equation is starting at negative 5 on the y-axis, and we got a positive 1 slope, which is up 1, right 1, up 1, right 1, up 1, right 1, and continue that pattern. Whereas we go down 1, left 1, down 1, left 1, down 1, left 1. This time it is also dashed because it is less than. But this time we are going to go below because it's less than, so that means this area. Okay, anything below that line. Now here's where we shade. So I want to shade where it's above the first line but below the second. And if I look at my arrows, where I focus is where it's above and below is this area right here. So that's the only part that I shade because it applies to both. It's above this line but below that line. So it's that shaded region. So that's why we wait to shade until after we've graphed both. Number two, the second one's already in slope-intercept, so we do only have to convert the first one by adding x. So 3y is less than positive x plus 21. I'm going to divide everything by 3. So y is less than x, 1/3 x. 21 over 3 simplifies to 7. So then I graph both. I'm going to start with this first one. Positive 7 on the 1, 2, 3, 4, 5, 6, 7. Missed that by 1. Positive 7 on the y-axis. 1 over 3 is up 1, right 3, up 1, right 3, up 1, right 3. Down 1, left 3, down 1, left 3, down 1, left 3. It is a dashed line because it is less than. And we are going to shade below. So I'm just going to use arrows for now to remind me that I need to shade below that line. The second equation is already in slope-intercept, so we're going to start at 4 on the y-axis. Negative 1 over 1 means down 1, right 1, 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 up 1, left 1, up 1, left 1, up 1, left 1, up 1, left 1. It is greater than or equal to, so it is a solid line. And greater than or equal to means above, so that means the region above. Okay, so where I shade is where it's below the first line but above the second line. If you look at my arrows where they're pointing towards each other, that's this region right here. Below the first line but above the second line. Just right there, okay? So we're gonna just do that for a couple more practice problems. It's pretty much the same over and over again. So number 3, we first need to convert to slope-intercept form. So this first one, we subtract x, so negative 4y is less than or equal to negative x plus 24. Going to divide everything by negative 4. So y is, because I divided by negative, it flips that symbol to greater than or equal to. Negative x over negative 4 is positive 1 over 4x. Positive 24 over negative 4 is minus 6. Then the second equation, we're going to subtract 2x, so negative y is greater than or equal to negative 2x minus 1. Divide everything by negative 1. Since I divided everything by negative 1, we're going to flip that inequality. So negative 2 over negative 1 is positive 2x. Negative 1 over negative 1 is positive 1. So I'm going to graph both. The first one, we're going to start at negative 6. And it's going to go up 1, right 4, up 1, right 4, down 1, left 4, down 1, left 4. It is a solid line because it's greater than or equal to. Greater than meaning above, so I'm going to use arrows to help me there. Okay. The second equation, it starts at positive 1. The slope is 2 over 1, so I'm going to go up to right 1, up to right 1, up to right 1, up to right 1, down to left 1, down to left 1, down to left 1, down to left 1. It is a solid line also. And this time below, because it's less than or equal to, below would be this direction. So we want above the first line but below the second. Above the first line but below the second. Where these arrows point towards each other is my area that I shade. Okay. So my solution would be anything in that shaded region, or on this line or on that line, because they are solid lines. Okay, number 4 has a special case, so we'll worry about that here in a minute. But we're first going to convert the second one to slope-intercept. So we're going to subtract 3x. So I have 2y is less than or equal to negative 3x minus 2. Divide everything by 2. Since I did not divide by negative, we are going to leave it less than or equal to. Negative 3 over 2 is negative 3 over 2x. Negative 2 over 2 is negative 1. Okay, so how we graph the number 4, the first one, is on the x-axis where negative 4 is, it's going to be a vertical line, and it's going to be a dashed line because it is less than. Less than negative 4 is anything to the left, so I'm going to point my arrows to the left. The second equation, it starts at negative 1. We're going to go down 3, right 2, down 3, right 2, down 3, right 2, up 3, left 2, up 3, left 2, up 3, left 2. And it's a solid line because it's less than or equal to. And it's below, so anything below, I'm going to draw my arrows. Okay, so this one's a little weird, but I want something to the left of that first line and below the second line. Left of the first line, below the second. So that means this section over here. Now, you're thinking, Miss, why can't I shade this region right here? It's below. It is below this line, but it's not to the left of the other line. So it has to follow both rules. So a solution would be anything in this shaded region or on this line right here because it's solid, not on this line because it's dashed. Okay? So just more practice problems. Kind of gets repetitive. So number 5, we're going to convert to slope-intercept form. So subtract 4x. Oops. So I have negative 5y is greater than or equal to negative 4x minus 35. Divide by negative 5. Y, since I divided by negative 5, we're going to flip that symbol. Negative 4 over negative 5 is positive 4 over 5x. Negative 35 over negative 5 is positive 7. The second equation, I'm going to subtract x. So y is greater than negative x minus 2. And that's the only thing I had to do for that one. So the first equation, we're going to start at positive 7. We're going to go up 4, right 5. Since I can't go up 4, right 5, we're going to go down 4, left 5. Down 4, left 5. Okay, it is a solid line since it's less than or equal to. Less than or equal to means below. Okay, the second line is going to start at negative 2 on the y-axis. It's negative 1 over 1, so we're going to go down 1, right 1, down 1, right 1. in the opposite direction, it's going to go up 1, left 1. Okay, it is a dashed line. And we want above, so we want anything above, which means this direction. So where it is below the first line but above the second line is this shaded region right here. Okay, so continuing on, same thing. Number 6, we're going to first convert to slope-intercept form. So I'm going to subtract 6x on both sides. 4y is greater than negative 6x plus 12. Divide everything by 4. So y is greater than, because I don't need to flip it, negative 6 over 4 simplifies to negative 3 over 2x. 12 over 4 simplifies to 3. The second equation, I'm going to subtract 3x, so negative 4y is greater than negative 3x plus 8. Divide everything by negative 4. Y, since I divided by negative, it flips that sign. Negative 3 over negative 4 is positive 3 over 4x. Positive 8 over negative 4 is negative 2. The first equation, I'm going to start at positive 3. My slope is negative 3 over 2, so I'm going to go down 3, right 2, down 3, right 2, down 3, right 2, down 3, right 2, up 3, left 2, up 3, left 2. Since it's greater than, that means dashed. Greater than also means above, so I'm going to go this direction. The second equation, I start at negative 2. It's 3 over 4, so I'm going to go up 3, right 4, up 3, right 4, up 3, right 4, down 3, left 4, down 3, left 4. It is less than, so it's a dashed line as well. Less than means below. Okay, so where it's above the first line but below the second line, where those arrows point to each other, is this shaded region right here. That means my solution is anything in this shaded region, but not on either line because they're dashed. Number 7 gives us a little bit of a break because it's both in slope-intercept form. So we're going to start by graphing on positive 6 on the first line. Since my slope is negative 5 over 1, we're going to go down 5, right 1, down 5, right 1, down 5, right 1, up 5, left 1. Since it is less than, that means it's a dashed line. Okay, and we're going below since it's less than, so below would be to the left here. The second equation starts at negative 1. Since our slope is 2 over 1, we're going to go up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1, down 2, left 1, down 2, left 1, down 2, left 1, down 2, left 1. Since it's greater than or equal to, that means it's a solid line. And since it's greater than or equal to, that means above. So where it's to the left or below the first line, above the second, below the first one, above the second, is where the arrows point to each other. So that's this entire region right here. Where my solution could be anything in that shaded region or on this line, but not this line because it's not solid. The last one, number 8, the first equation I have to divide by 8 to everything because it's not set to y equals. So y is greater than, negative 10 over 8 is negative 5 over 4, x, and 24 over 8 is positive 3. The second one's already in y equals, so here I'm going to start on positive 3. Negative 5 over 4 means down 5, right 4, down 5, right 4, up 5, left 4. Then it's a dashed line because it is greater than. Greater than means above, so we're going to go that way. The second equation is y is less than or equal to 2. So where y is 2 is on the y-axis. It's going to be a horizontal line. It is solid because it's less than or equal to, but it's going to be below. Okay, so where it's above the first line but below the second line is this little region right here. So my solution would be anything in this region or on the solid line, not the dashed.